So today we are continuing our lesson from yesterday. So if you haven't seen yesterday's video, you probably want to watch that video first, just because the first part of today's lesson is in that video. So I'm going to pick back up where that video left off. So just a refresher for us, when we're finding magnitude from x and y, we use Pythagorean theorem. Inverse tangent helps us find the angle measure, or the direction, and then depending on which quadrant we live in, we have to add something. If you're going the other direction, magnitude and direction to x and y, remember that it's magnitude times cosine of the direction and magnitude times sine of the direction. So it's just a little refresher for you. You should have that in your notes already. And then a reminder from yesterday, 90 270 is north and south, and then east and west, 0 and 180, so that's in the same orientation as your unit circle. Okay, and so this is where we left off yesterday, and so this part, if you haven't seen this part yet, or how we got here, you can watch that video. So this is where we're going to pick up. So a Boeing 757 is set to travel 475 miles per hour in the northeast direction, but the wind is also blowing 25 miles per hour in the southward direction. And so we found the x and y components from the magnitude and the direction in that last video. And so that's where we're going to pick up. So the next step in this is we want to combine the vectors of the wind and the plane. AKA, we're just going to add these two vectors together. So our new vector is $335.9, and then so that's 335 plus 0.9 plus 0. 335.9 minus 25 gives us 310.9, and so this is our combined vector. Once we have them combined, this is like the plane and the wind together. And we want to know what the new magnitude and the new direction for the plane and the wind together, what that would be. So it's like you're really figuring out what is the plane actually doing and what is the real magnitude and direction for the plane as it interacts with the wind. And so we're just putting some like real world information with adding vectors together. And so here, to find our magnitude, we're going to use Pythagorean theorem. And so our magnitude for vector v would be 335.9 squared plus 310.9 squared. And then we're going to square root that to get magnitude all by itself. And then inverse tangent, we live in quadrant 1, so this would be inverse tangent of 310.9 over 335.9. So our new magnitude is 457.7 miles per hour. And then our angle measure, 42.8 degrees. And so our new magnitude is actually slower than what we started. It started at 475, and so the plane has slowed down because of the wind. And then the course that it's set is a little closer to east rather than northeast, the way that the plane was set to travel. And so hopefully that makes sense. And yesterday we drew that picture. And so this one was the plane. This is the wind. And then it makes sense. It makes sense in our picture that the speed is shorter or smaller because the arrow, you can see that the arrow is actually shorter for the light blue one, and that the angle is closer, it's a smaller angle rather than the 45. And so hopefully the picture, I know some of us were struggling with the picture yesterday as we were adding vectors, and so hopefully this picture makes more sense when we've like added some real context to some things.